method, redundant data node, a replica of that. And this is where, when the master nodes talk to each other, you can even have them talk to a different part of the switch as well. And they can then communicate with the top and all these leaf switches. You can have all the data nodes. The data nodes can use the 1 gig, if you like, if you don't have a whole lot. But the moment you start doing more and more, switch them over to 40 gig and have the master nodes only on 1 gig, because their traffic is much, much smaller. Yeah?
Do you see dynamically allocated nodes where, like, you have a big push at a certain time?
Yes, yes. It can be done very dynamically on the fly. You can actually specify high watermarks, upper bound, lower bound, and it can work with that. This is where it's a very natural fit for cloud vendors, so you can create a lot of VMware instances on demand and use that, push that, create and destroy. So it's very dynamic and very flexible out there. Okay, a little bit on the Hadoop, a little bit of the stack. They actually have their own data warehouse now called Hive. It comes with the file system and the MapReduce, and there's the file system out there. It also has a NoSQL database called HBase, but there's another Cassandra, which is written by the Facebook people, and now it's part of the Hadoop system out there. And this you can use for the security at the top. And then you can actually layer your own analytic tools on top of this, expecting this infrastructure, if you like, and then let it use. And this is where all the work gets done with the file system and the MapReduce engine. This all put together is actually Hadoop. So it's really a collection. It's not a single product. It's actually a collection of all of these. And often in conversations with these folks, they'll jump from here to here to here, so you have to keep track of what the hell are you talking about here. So that happens a lot. Someone also asked me, where the hell did they come up with the name Hadoop from? Well, the genealogy or explanation, which is true, that happened was, I think in 2004, Google published 2 papers on how they did their own internal web search and database. They actually published papers like a research paper in the conference and all that. But they didn't give any code. But they gave the philosophy design that this is how it works. We split this up, this and that. And there was a fellow by the name of Doug Cutting at Yahoo. He read that and he was inspired. So then he worked for the next year and a half and created an open source version inspired by that. And those 2 papers, one was the file system, and the other was the MapReduce engine. Then how you would then reduce all the stuff and synthesize the results and get it back. And he wrote an open source implementation of that at Yahoo, so that he could use it internally in Yahoo for the web search to speed it up, make it better. And you know, he designed it for a 10,000 node cluster that he could use inside. He didn't have a name for it, and then one day his kid, 3-4-year-old kid, was playing with a little blue stuffed toy elephant, and he said, "Oh, who's that?" And the kid said, "Oh, that's my toy elephant. His name is Hadoop." And so he liked the name and he named it Hadoop. Yeah. So that's why you see that little.
It's not an acronym for anything. It's
no, it's
a toy.
Named after a kid's toy.
Yeah.
That's the story behind that. And like everything else, people have come out with benchmarks for a Hadoop implementation, which means it should have all of these pieces out there for it. And it's called HI bench, and it comes with a few standard things: sort, word count, terabyte sort. And you'll often hear people saying, our implementation of Hadoop, we did these tweaks or this tweaks, and we cut down on the replication factor so that we'd have smaller packets transmitted to the network so that they could do a terasort in, I don't know, 1 minute or something like that. The comparison, if I remember correctly, and it changes every year as you get different nodes with more memory or faster CPU or whatever, ECC3 or something like that, or sorry, DDR3 or things like that. Like a terabyte sort, if you did it on a single node, I don't know, 10 minutes, you put in 10 nodes, you actually can get it under a minute. Yeah.
Mhm.
Okay. So that's what proved that it is scalable. The more nodes you throw at it, the more faster it gets it. And then Nudge was actually one of the implementations in the original Hadoop. It doesn't show up out here, but that was the web searching, and it does indexing and page ranking, again inspired by Google. That's how Google got popular. They would rank pages. The ranking of the page was how often did one website reference another website, and the more it referenced, it got a higher page rank, and that's how they did their indexing, and you got your Google results. So they have benchmarks for this. And then there are people with enhanced distributed file system I/O, and they can do all sorts of things. That's why when we had the Ceph file system talk, I was quite curious. And I think he mentioned that there are people who actually, instead of using HDFS, they've actually put in Ceph, and they've gotten pretty good results. And then there are two things, and this is itself worth at least a couple of hours on what are the techniques and methods that you can teach a machine. You can have canned configuration scripts that have a certain learning method, and you can implement that. And maybe Craig, you can, tell us a little bit about that. But they actually, this one, K-means clustering, is a lot more popular, but they have benchmarks for those as well. So combined with the file system and the analytics, you can report those two numbers up there. Okay, and now trying to wrap up so you have a little time. And I did, if you remember all the way back, the last was like HUH question mark. And I did tell Jim, I will give you warning. There are plenty of groaners ahead. So if you like, you can close your eyes or walk out of the room. But this certainly, whenever I get into a topic, I gather everything about it. And you can't be all dry and philosophical and boring. So I thought this looks better. Yeah. So this is how, one way of getting dates here. You find someone who gets excited by this sort of stuff. So if you find any of those, let me know. Yeah. Large-scale analytic queries on unstructured data. That's what he's describing. Hadoop for big data. Okay, and then the public at large. Well, I think it's enough for them to say, yeah, it's too much information. Yeah. So, and you all know what MOOCs is, right? Massive online open courses. Yeah. They've actually showed 100,000 people registered for a course at one time. Yeah. Just kidding. But there's one on big data and what you need to know, but as far as the people are concerned, there's too much information that's just going on. If you asked a librarian, or if he asked you what's big data, you can say, hey, if they were like, this is what it will look like. Yeah. All the table of contents of all the pages would be ripped out, put in one column. All the covers ripped out, put in another column. The index, rip it out, put it there, and chapters, that's where you'll find it. But that's the way it actually works. Yeah. Not libraries, but our Google search engine. And then now for some really bad ones. So practice your groaning right now. I didn't like this, but I thought, hell, somebody out there published it. This is 2013. Actually, maybe working on it burned them out there. Oh, this one I liked here. If we put all our data in the cloud, will it get lost if there's a thunderstorm? Okay, and then of course we all have our favorite management, This is their typical request. Oh, no big data, you can make things fast, do this for me.
Okay.
Ted Goff, I like his cartoons, he's a funny guy. There's a few more in there. And then the Wall Street type, yeah, he's always there. Right, glad you like it. Oh, let's see how we can make money out of it. Yeah, plenty of quarters. I'd like to be at the other end of that quarter, not with just buckets, with the gigantic PVC pipe, and then have it all go into Bitcoins or something. Oh, okay. Hey, don't forget your Star Trek guys out there. This is what big data means to them. Okay, well, not everyone is a Star Trek fan, so this is what it means to the guys who are really, really. It's only small, few useful pieces of information. The rest is all fluff. Yeah. Lots of fluff. Oh, of course, how can we not forget our teenage, kids out there? And this is what big data means to them. When they asked me, I said, hey, this is what it means to me. Oh, okay. I like this one, yeah. So if you're in the market looking for jobs, okay, yeah, and then into healthcare. Ah, hey, I took care of everyone, yeah, even the folks in the afterlife industry. Yeah. And of course, there's the folks who hate it. Oh, and then we all know somebody, maybe some of us have done this ourselves, yeah. Okay. And then another one about our clueless management.
Ones and zeros.
There you go.
Zeros.
Okay, sometimes it does get a bit much here, so here we go. I like this one. Oh, geez, sorry. Oh, yeah, this is a good one too. Erlang is a very popular language with some computer science geeks. Whether it's R or Python or Erlang, you can do it. And then, of course, how can you forget this guy? And then, oh yes, of course, once in a while this happens to you. So you got to create something. In the old days, we just run up a spreadsheet and show a different graph here.
Right, yeah.
And then one more. Oh, this, of course, What was it in the description? You can't swing a dead cat without hitting some jargon? Oh, there you go. And this is true. If you go to Oracle's webpage where they talk, where do big data? They talk about in-memory computing and how it will accelerate your applications. And with that, I'd like to conclude. And this is also in recently, so I had to include it. But enjoy. All right. Thank you very much. Thank you.
All right, I think get up and stretch a little bit.